let's do just a couple examples of finding cosine and sine values on the unit circle. This is really very similar to what we've been doing already, we're just connecting it with the terminology of cosine and sine that we already know has to do with triangles. So here's an example. What is the cosine of minus 4 pi over 3? Now, this number, it's not just because it has a pi in it. That's a hint that it's probably radians, but really it's just that it doesn't have a degree symbol. Even if it doesn't have a pi in it, it means it's radians. So, but where is minus 4 pi over 3? Okay, I purposely picked a little bit of a tricky one. Minus means that you start from the base point here and you go in the clockwise direction. And you're going to go 4 pi over 3s. Well, pi over 3s, it's really important to remember that pi over 3 is 60 degrees, or this much of the circle. So you go one of those, then another big, so these are sixths of the circle going 1, 2, that's minus 2 pi over 3. And here's minus 3 pi over 3. Well, that's good. That should be minus pi. That's halfway around the circle. So you could just jump to there if you wanted. And then one more up to here, minus 4 pi over 3. So that's where minus 4 pi over 3 is in radians. Minus 4. Go away. I hate you. Okay. I don't know why it shows me that message every time. Minus 4 pi over 3 is right here. It's this point. And then what's the cosine and sine of that? Remember, on the unit circle, all that means is the x value and the y value. Okay, so we could drop a perpendicular. I'll do it just freehand, although I should do it more exactly. Okay, and then we've got a triangle. Hypotenuse equal to 1, and then the y is the sine and the x is the cosine. Now, it's on the left-hand side. It's in quadrant 2, so this is going to be negative here. But it's going to be the negative of its partner over here. Another way to say that is the reference angle is the angle to this axis. The x-axis is 60 degrees. It's going to have these values that come from pi over 3 or 60 degrees over here. You just have to get the signs right. So the y, the x is going to be minus 1/2, and the y is going to be plus root 3 over 2. And so it's just going to be very much like this point. And so that's the cosine and sine of those values. Now, this isn't really new. It's just that if we had this triangle, the ratios in that triangle are 1 to 1/2 to root 3 over 2. It's a 30, 60, 90 triangle. We are doing triangle trig on this triangle, but we're putting it in an interesting position. We're getting this negative value because we're remembering that it's in a different place from over here. It's similar to over here, but it's different with the minus. Now, here's another kind of problem real quick that you'll have, which is something where the angle isn't particularly nice. It's not even known. All we know is that the point on the unit circle, let's say, is given by, let's just put a point in here, and let's say the point is given by 5/13 comma 12/13. So roughly it's going to be like here. I'm just freehanding here. Okay. So we've seen that sometimes points are special not because their angles are nice. That's actually 12/13, 5/13, sorry. Said it in the wrong order. Not because their angles are nice, but because their coordinates are nice, or the side lengths, like the side lengths of this triangle, are nice. And this is, we've seen that these guys come from Pythagorean triples, where all the numbers are fractions. You could scale that up to a 5, 12, 13 triangle, this triangle here. This is a really easy problem if we know what we're doing. There's no calculation required. The cosine is this number. We're done. You're staring at it. There's no calculation necessary. And in particular, we don't need to find this angle and then like punch it into a calculator. This, I give you a point on the unit circle, the x-coordinate is the cosine. The cosine of this angle, what do you want to call it, t, theta, whatever, is 12/13. The sine is 5/13. And then often they ask you for the tangent. Well, the tangent is the ratio of these two sides, or in other words, it's the ratio of the y and the x. Here, the tangent of, let's call it t, let me put a little space in, is going to be just 5/12. Because when you divide them, the 13ths cancel. Okay, that's another kind of problem, but we're often going to see that as well.